Cardiac electric activity is registered by electrodes. Electrodes can be positive and negative. Electrodes form ECG leads. For example, standard first lead is formed by one negative and one positive electrodes. Augmented AVR lead is formed by two negative and one positive electrodes. Precordial V1 lead is formed by electric center of the heart and one positive electrode. We will discuss in details every type of lead, but even now it's obvious that positive electrode is present in every type of lead. It's because heart electric activity on ECG is depicted only by a positive electrode. That's why positive electrode, also called active electrode, and to distinguish two of them, active electrode is marked by an arrow. For example, in hexaxial system it's first lead. There is negative electrode, there is positive electrode. Positive electrode is marked by an arrow, and heart electric activity that we see on ECG as first lead is registered only by positive electrode. Or for example, precordial leads. There is V1 lead that is formed by electric center of the heart and positive electrode that is marked by an arrow. And heart electric activity that is represented on ECG as V1 is depicted by this positive electrode. This concept is essential to remember. So, as we already discussed, positive electrode registers cardiac electric activity that we see on ECG. That's why this electrode also called active electrode. The next important concept is that electrodes measure only the difference in electric potentials between 2 points. The difference in electric potentials basically is a relation of positively charged cells to negatively charged cells. So for example, there is 50 cells and there is negative and positive electrode. And if all 50 cells will have the same charge, it doesn't matter it's positive charge or negative charge. There will be no difference in electric potentials because there are no cells with opposite charge to form the electric difference. And for example, if 10 cells are negatively charged and 40 cells are positively charged, there is a difference in electric potentials. But this difference is relatively small because the dominant charge is positive charge, and there are only 10 cells that are negatively charged. We can say 20% of this tissue have opposite charge, so there will be only minimal elevation from isoelectric line. But if 25 cells have negative charge and 25 cells have positive charge, the difference in electric potentials became maximal, because half of this tissue depolarize and have negative charge, and another half is non-depolarized and have positive charge. So if between electrodes the quantity of negatively charged cells is equal to quantity of positively charged cells, there is the maximal difference in electric potentials, and active electrode depicts this as maximal elevation from isoelectric line. So the maximal difference in electric potentials occurs when the quantity of depolarized cells is equal to non-depolarized cells, or we can say that the quantity of positively charged cells is equal to quantity of negatively charged cells. If there is no difference in electric potentials, active electrodes register isoelectric line, and with maximal difference in electric potentials, electrodes register maximal deviation from isoelectric line. Now knowing these concepts and the mechanism of the action potential, we can discuss the principles of the vector formation and how electrodes register them on ECG.